So welcome everyone, I'm Csenger Szabó, and I'm going to talk here about how demands are changing in business intelligence. I would like to share my opinion about how notebook-like applications could fit into those environments. In my first part of the presentation, I would like to share you some facts and some statistics about business intelligence today. In the second part of my presentation, I will show you a demo of a notebook-like application. You have seen already notebooks today. Also Esther and Zoltán Cétót have talked about Jupyter notebooks. I will talk about another one, and I will show you another one, Apache Zeppelin. How many of you knows Apache Zeppelin? Okay. So, and in the last part of my presentation, I'm gonna take some conclusions. So, some words about who am I. I've spent some years in multiple fields in IT. I was system engineer, and also I was in software development. And after that, I finally pledged allegiance to big data. So, and now I'm working at Nextent and helping them with the big data strategy, and also assigned to Magyar Telekom, where I'm working on enterprise big data projects. Yeah, so if you would like to see my other stuff, I have a blog about big data. It's spready.com, so you can check it if you're interested in. So let's jump into my presentation. The beginning of BI. How many of you guys think the term BI was firstly mentioned in professional literature after the 90s? Hands up. No one. How many of you guys think it was firstly mentioned between the 50s and the 90s? Few of you. And how many of you think that it was firstly mentioned in the 19th century? This was the right answer, actually, the third one. Actually, in 1865, there was an author called Richard Miller Devons who has written a book called Commercial and Business Anecdotes. And he has written about a banker who gained business profit with accessing the hottest news on the market, for example, political issues in other countries and battles, of course, that time. Yes, that was business intelligence that time, and they named it that time already. But after that, I think we took a long path to today's BI, and now you can see the official definition of business intelligence, which is, in my interpretation, a set of techniques and tools in order to turn raw data into valuable information to gain business profit or business analytics purposes. And yes, the next slide. So in my perspective, I'm a data guy. So as a data guy, business intelligence is simply the connection between the data teams and the top managers, the business decision makers. So it's the communication channel between them. And nowadays, this communication channel is going to be, or the two teams is going to be closer and closer as business around us is going to be faster and faster thanks to new technologies like the big data stack and all the other automation in business processes. So, according to Bain & Company, yes, we all know that business analytics has become a business standard today. But according to Bain & Company, they measured how important is using business analytics, and they say that companies who use this business analytics among top performer companies are 5 times more likely to make much faster decisions. And it's really important on the market that how fast can you make a good decision. And we are just talking about the speed of decisions, but it's also a really important thing that how fast can you deliver business intelligence solutions on which you can make decisions. So, according to Aberdeen Group, they've made a research about the time needed for creating business intelligence applications, or not applications, but solutions, so reports, dashboards. And they've measured among also the top performer companies, it needs in average more than 6 days to create new reports with traditional BI tools. And I think in the days when we live in the age of information immediacy, it seems like a little bit too much. So I think people now, especially top managers, would like to get what they want when they want it, and then not after that. So, and they also, according to Forrester, they also sees this problem. 60% of decision makers sees a time concern about creating and updating today's dashboards. And also a big amount of decision makers sees a lack of alignment and cooperation between the IT guys, the data teams, and the business decision makers. So, how comes notebooks here? As we have already learned today, notebooks are web-based, mostly web-based applications when you have blocks on the user interface and you can put code snippets into the blocks. You can run them inline and you get the results instantly of your code. And you are also able to visualize instantly your data in the notebooks. So that they've become the best friends of data scientists by today. And why is that? Because they provide multiple data sources. So you can interact to multiple data sources and you can use multiple interfaces to interact those data sources. So it's a really big weapon in your hand when you are using notebooks. The other thing that you are able to do all the aspects of a data project in one notebook, so in just one tool, and you don't need another one. And also sharing and presentation is solved in a notebook, so you can present your data, you can publish a dashboard of your notebook to the top managers. So, before the demo, I'd like to compare the traditional BI tools and a notebook. And I think the first aspect which has to be compared is the interaction with data. In a traditional BI tool, you most likely interact with your data via SQL. But in a notebook, you can do it with SQL and also programmatically, which is a really important thing because not everything could be solved in SQL, in only SQL. So, statistical analysis. Talking about statistical analysis, in a notebook you have fully access to several libraries in multiple programming languages. While in a traditional BI tool, or in some of BI tools, of course, are capable of really good statistical analysis or data mining, but you have to have another tool then for data visualization. And if you're using that kind of tool, it don't support a really deep statistical analysis possibility. So then, okay, there are some, for example, in Tableau you can put R code snippets, so it can be solved. But you can, in most cases, you have to use many tools for just one data project. And data cleansing is also limited, and the data quality it needs thus is usually prepared data. So you have to use another tool to prepare your data, which you will use for dashboard creating. Yeah. Meanwhile, a notebook can eat almost everything, and you can do whatever you want, for example, in Python, to cleanse your data. Visualization and shareability. Yes, I have to admit that the traditional BI tools are developed for enterprises. So they are really well developed in these two scenarios. And it's really easy to visualize your data in a traditional BI tool, and really easy to share and control the permissions among users. But among notebooks, for example, with Apache Zeppelin, there are initiatives to create cloud platforms, which I'm going to show you, where you can apply permission controls and share your notebooks, for example, to the managers. Yeah, and skill set and tools, which I've mentioned already, that in a traditional BI, when you are using traditional BI tools, you have to use more tools for one data project, because you have to use an application for data cleansing, you have to use another for machine learning model building, and another one for visualization. In a notebook, you can do all these things. So, it was, I think, enough talk, so I'm going to show you a little demo. Okay. So, we are here, and what you're seeing now is Zeppelin Hub, which is a cloud platform of Apache Zeppelin, and here you can create spaces, you can do permission control, and you can upload your notebooks and share them with the others. For example, I have a notebook here, yes, and I did a little data project in this. So I used data from the Open Data Platform of the US, and it's about population changes between 2010 and 2015. It's just data for fun. The first few blocks, I wanted to try to use a non-default interpreter of Apache Zeppelin. Thus, I've used MySQL database connected to Apache Zeppelin on a Docker container. And thus, because Apache Zeppelin has JDBC connector in it, you can connect it to any database which has a JDBC connector. So I've connected to my MySQL database. I loaded some data into my table from a CSV file, which I've downloaded from the Open Data Platform. And after that, I immediately able to create some analytics. And I've just done a SQL, and it instantly creates for me a visualization of the data. You can see now the changing of the population in the biggest US states. And after that, it was just for fun, and after that I would have liked to use Spark for data analysis, because Apache Zeppelin is mainly created for Spark and Flink. And so I've secure copied my CSV file from my MySQL Docker container to my Spark Docker container, and I've just done it from my notebook. So I think it can barely be done with the traditional BI tool to copy a file to from nodes to nodes. You can also apply third-party dependencies, and you can put them in line your notebooks and immediately apply them in your code. After that, I've created a Spark data frame, which was already mentioned today, and registered a temp table, and after that I can use Spark SQL as well. And also with Spark SQL, I've got visualizations instantly, so I don't have to use codes for visualization of my data. For example, just for the fun, here you can see the differences of populations by year to year in the smallest US countries. And you can see that here there was some problem in this country. Let me check. Which was it? Yes, it was West Virginia. Let's find out what was the problem. The problem of the population, or the decreasing of the population, can be caused by two things. It can be caused by there were more deaths than births that year, or there were more people who were going out from the country than the people who are going in. Let's check the first case, the death and birth ratio, and I used Spark SQL for that. And yes, we can see that there were more deaths than births in 2013, but probably not that was the reason, because we can see that that wasn't a big change between the 2 years. So let's check the other reason, the migration. Yeah, and meanwhile, I've played a little bit with passing my Spark objects, my Scala Spark objects to Python, and used pandas to make some other stuff. But after that, turning back to this question, this is the migration. I've also used Spark SQL, and we found out that there was a big change in the migration in between 2012 and 2013. So there was some problem in the country about migration. Yes, it's West Virginia. It's real data. You can check it on Wikipedia. And if I remember well, they also write about this problem in West Virginia. So it's a fun fact. But showing how could it be a dashboard? So what I was done, I've just closed on my notebook my code snippets, and I only let the visualizations on the dashboard. And now we've got a fully functioning dashboard here. So as you can see, here's a notebook is runnable text, which means you're able to run your code remotely if you have Apache Zeppelin notebook online, so on a server. And in Apache Zeppelin, there's a possibility also now to create cron jobs, so you can schedule your jobs and code snippets when to run next time. So if you have a streaming data or data what is coming in batches, you can create cron jobs on it and refresh your visualization fully automatically. So that was Zeppelin and Zeppelin Hub. And turning back to my presentation. I don't know how many of you guys have heard about the 8 levels of analytics. Raise your hands. Okay, so 8 levels of analytics is a paradigm of business intelligence, and the goal of it is to separate business analytics processes into 8 levels, starting from the easiest one, and it ends with the most complex one. So let's see. I just would like to check if a notebook like application like Apache Zeppelin could fit these levels of business analytics. And I think it could fit most of them. For example, let's check alerts. It's an interesting one. If you would like to create an alert, you can do it really easily with a few lines of code in Python. You can send emails if something happens in your data, as you can create cron jobs. So it can also run fully automatically. Okay, so now I think it's time to have some conclusions. The first conclusion, I think, is time is money, so sharing has to be fast. it doesn't matter if you have a big data architecture with Hadoop and Spark and Impala or whatever, and our queries run really fast, much faster than before, but it doesn't matter when our delivery time remains the same. And thanks to using a bunch of traditional BI tools. And it leads us to the second point, which says that if you have more tools, there's a bigger chance that you have to have more people assigned to each tools, because there's a tool for ETL, there's a tool for data visualization, there's a tool for data mining and machine learning. But instead of it, if you have just one tool, one notebook, and do all the data project in one notebook, also the dashboard creating, it's a bigger chance that it can be done much faster with just one data guy or data scientist. And we all know that we are living now in the triumph of open source and also web-based applications, and of course the cloud. Why do I say that? Because notebooks have all these three aspects. So I can say that they are really a future-like applications. And in the end, we all know that business is continuously changing. So I think we have to keep up with this changing industry, and we have to dare to use the hottest tools in the market, and don't be afraid of them. And in the end, with those tools, I think we are able, and not just able, but have to create much faster decisions, much faster delivery, and also more precise business analytics. So this was my presentation. Thank you for your attention.